Mike and Steve, are you out there with me today?
Yes, I am.
All right. Just want to thank everybody for joining us for the 2018 severe weather forecast. Depending on where you are, it might not feel like spring. We've got a big nor'easter going up the East Coast. It's sunny here in Norman, Oklahoma. Steve, what's the weather like up there in Tulsa today?
Sunny and a lot calmer after yesterday's high winds and dust storm.
Oh, did you get a little dust storm up there?
Yeah, dust and smoke from a fire to our north, so a kind of a typical spring Oklahoma, or early spring Oklahoma day.
Yeah,
lots of wind, lots of dust.
Yeah, I think we got winds up to 45 miles per hour here, and of course that's a sign of the seasons changing. Mike G, have we been able to connect with you here? We're expecting an active spring, and the first person I want to introduce today is Steve Strum. Steve Strum is our Vice President of Extended Forecast here at WDT. I'll start off by asking you this question, Steve. What is your favorite part of spring?
Probably the severe weather, which kind of fits pretty well.
Absolutely.
Obviously, so anyway, we are going to talk about the spring outlook, including the severe weather portion of that. And so we'll kind of go through here some of the factors that are kind of leading into this spring season. Now, obviously, we've had a La Niña winter that has impacted things across not just the U.S., but the overall global patterns around the world. And we do still have that lingering La Niña in place across the equatorial Pacific. So if you look on the top right-hand side there, you can see a map of global SST anomalies. Inside that rectangular black box is the equatorial Pacific areas that we're kind of focused on. And the blue areas in there indicate the areas where water temperatures are lower than normal. And you can see, obviously, that we do still have a fair amount of cooler than normal water across the equatorial Pacific. However, if you look below the surface to that map on the bottom right-hand corner of the page, you can see a large area of the western and central Pacific Ocean is actually warmer than normal now in those subsurface layers. And that warmer water has been spreading eastward with time. And so we are going to likely see a transition here from La Niña that we've had in place the last several months to more of a neutral ENSO regime as we head through the spring season. And on the left-hand side there, you can see a plot from various climate models that show the overall projection of temperature anomalies going forward here through the balance of the year, actually. And most of those lines kind of trend upwards with time, as you can see. And between the red line and between the blue line would be the neutral ENSO phase. If you get above the red line, that would indicate an El Nino regime. And so some models do actually show El Nino developing later this year. A few keep La Nina in place throughout the year, but the bulk of them kind of trend into that neutral ENSO regime, which is what we're basically expecting, at least through the spring season and into early summer. If things evolve past that into an El Nino later this year, we'll have to wait and see. But at least for the bulk of the spring and early summer, we should be looking at mostly a neutral ENSO type regime. So what does that mean? So if you look at the bottom here of this next page, you can kind of see how patterns have trended in the past coming out of a La Nina. On the left-hand side is a map that shows average temperatures where La Nina had persisted right on through the spring into summer. At the middle there, where we've seen a kind of a transition from La Nina to neutral ENSO during spring, and on the right-hand side, where we've gone from a La Nina to an El Nino by summer. And so you can kind of see, in general, one key area that kind of jumps out is that in all scenarios, the southwestern part of the country, especially from Arizona to Texas, usually averages warmer than normal, regardless of how the ENSO pattern evolves. And that also kind of matches the 10-year trend that we've seen in recent years as well, that has favored a lot of the southern U.S. being warmer than normal during the spring season. And so our forecast kind of reflects that. We are expecting most of the southwest and the south central U.S. to average warmer than normal across those areas. We also likely will see the northeastern U.S. average warmer than normal, while areas in between will likely more or less tend to see a much more variable pattern and average closer to normal for the entire spring season as a whole. Now, northern areas will have the best chance to see colder than normal weather, especially if we do see this pattern transition into a neutral ENSO regime, which is what we're expecting. And so we could be seeing a few more late season snowstorms across those areas as we head into April, but likely most areas are going to be trending on the warmer than normal side of things across the country, with the exception of that far northern tier. Now, if we kind of progress along here, look at the rainfall side of things. If we look at the southwestern U.S., the bottom right-hand map shows rainfall and snowfall anomalies for this past winter in terms of overall precipitation. And we did have a fairly dry winter across the Southwest after a very wet winter last year. So kind of a flip there. Oh, we've seen some rains recently and mountain snows across California the last couple of weeks. But in general, that area was dry during the winter season. And those areas also tend to be dry during the spring coming out of a La Nina winter. Now, we also saw some heavy rainfall in recent weeks across the Ohio Valley down towards Arkansas, as well as up into parts of the Northeast. We're getting more rain and snow there today. And those areas typically average wetter than normal as we come out of a La Nina winter during the spring months. And so the years on the left-hand side there, you can see when La Nina persists during the spring, we tend to be even wetter across the Ohio Valley areas and see more flooding concerns. The areas where, the years where we kind of transition back to a neutral ENSO regime tend to be not quite as wet, but still on the wetter than normal side of things across those areas. So since we have had some heavy rainfall in recent weeks across the Ohio Valley into the central Appalachians, if we do see additional heavy rains going forward here, during the spring season, those areas will be the areas to watch for flooding risks, while areas in Texas and into the Southwest and maybe the far southern areas of the Southeast towards Florida, where it's been dry this winter, those areas likely will stay drier than normal going forward through the spring. And so we'll have to watch those areas for more drought concerns. Now, if we look at severe weather, looking at climatology here, first off, on the right-hand side, you can see the average number of days per year that see a severe weather event within about 25 miles of any given point on the map. And you can see, for the most part, areas east of the Rockies typically see, a good number of days between about 10 and 20 days per year with severe weather within about 25 miles of any given point. Areas from Oklahoma and Kansas eastward to the Carolinas tend to see even more activity. If you look at the left-hand side, you can see that same plot for wind, hail, tornadoes, and you can generally see that kind of bullseye of severe weather activity across the Carolinas is largely driven by high wind events. As you head westward towards the plains, you tend to get more tornado and hail events, and not quite as many of the high wind events in those areas. Now, if we look at last year, you can see plots here of the actual number of tornadoes, hail events, wind events that were observed during 2017 across the country as a whole. And so you can see, for the most part, most areas east of the Rockies did see quite a few areas of severe weather. And really only the western areas of the country were pretty quiet in terms of severe weather. Now, if we look at just tornado tracks since 1950, you can see here across, again, the areas between the Rockies and the Appalachians tend to be the areas that are most at risk for tornadoes in most years. And that's what climatology is shown here. When you get to the Rockies and areas farther west, where it's much harder to get the conditions that are favorable for tornadoes, you don't tend to see as many of them. And so, again, those central portions of the country tend to be the main focus areas for the most intense severe weather during most years. And that will likely be the case again this year. Now, as we progress forward here, looking at overall tornado tendencies, which is kind of a proxy for all severe weather and how that kind of varies by time of year, you can see certainly there is a strong peak in the spring season between the months of April and June, but that does vary a lot by ENSO phase. On the right-hand side is a plot. There's a blue line, a black line, and a red line. The blue line indicates the years that came out of a La Nina winter. And so when we do have a La Nina in the winter, the following spring does tend to see a stronger and an earlier peak in overall severe weather activity. And so we tend to see this strong peak in April and May with tornadoes and overall severe weather, whereas the red line is the El Nino years. And those years, we tend to see a delayed peak in severe weather and also more of a shift into May and June. So those years tend to see a little bit of a delayed severe weather season, more of an extension of the season into summer. But years like this, when we've had a La Nina during the previous winter, those years tend to be much more active during April and May, but then actually kind of quiet down faster as we head into the summer months. But if you look at the bottom, you can see some numbers here. Coming out of a La Nina, we've averaged over 1,500 tornadoes per year during those years that follow a La Nina winter, whereas all other years have only averaged less than 1,200. So certainly quite a bit more tornado activity and overall severe weather activity when we do come out of a La Nina. The years, though, that went from a La Nina to an El Nino, where the La Nina weakened very quickly, didn't tend to see as many tornadoes, but still more than the overall average for years, for the neutral ENSO years and for the years that had an El Nino. So overall, again, when you have a La Nina during the winter, we tend to see a more active jet stream pattern across the U.S. and overall a greater frequency of tornadoes. And last year, the green line on that plot on the top right, again came after a weak La Nina winter, and that followed that La Nina curve pretty closely in terms of when the peak occurred and how fast things quieted down thereafter. Now, looking at spatial and time trends, during March here, this first plot or set of plots, you can see that overall we tend to see a focus of severe weather activity across the southern tier of the country towards the Gulf Coast and the southeast. As we progress through the spring season, that activity tends to shift farther west and north with time. So April and May tend to be a focal area across the plains, the Midwest. As we head into June at the tail end of spring, we tend to see more of that activity shift northward into the upper Midwest, and that kind of tends to be the main focus area on the tail end of spring. Although last year, certainly we had a lot of tropical activity along the Gulf Coast, and we do a lot of times see sort of an uptick in severe weather along the Gulf Coast just because of that, as we head into summer, because of that influence of severe weather that's generated by tropical systems. We had that with Harvey last year in Houston, for example, where we saw a lot of tornadoes from the tropical system. And so we do sometimes see a secondary peak later in the summer across the South if we do see a lot of landfalling tropical systems. So that's always a concern too down in that area. But for the most part, as the season progresses, we tend to see a general northward shift in the areas that are focused in terms of severe weather. So wrapping things up here, again, most of the country is likely to be warmer than normal during this spring season. As we progress forward through the spring, we likely will see a continuation of a dry trend across the southern tier of the country. Again, the Ohio Valley will be a little bit more at risk for heavier rainfall, and so those areas will have to be watched for additional flooding concerns. And then again, we are looking to have a more active and normal severe weather season, especially during the months of April and May. And so with that, I'll pass the call back to Rennie if he's back on, and he can carry us through the rest of the presentation.
I am here. Can you hear me okay?
Yes, I can.
Awesome. Well, you can't get that kind of information from a groundhog. We know that much, but really good info there. I really liked one of your slides, Steve, that emphasized that you can't get or that severe weather is not just limited to Tornado Alley. And looking at the climatology, there's severe weather can happen anywhere really at any time. And so, you know, for our goal is to help companies be prepared for events like that. And so now we get to welcome in Mike Gauthier into the webinar. And I hope that Mike made it this time around. Are you here, Mike?
Can you hear me?
Yeah, we can hear you. Awesome.
Good. I'll take control here if you want.
Yeah, go ahead. Mike Gauthier has been around the weather industry for a long time. In fact, I think one of his first sales in the weather industry was to NOAA as he was building his ark. So you've kind of seen it all and worked in a lot of different industries and helped people get weather prepared. So we'll talk a little bit about those tools today and things that we can get companies to use to be prepared for severe weather. So Mike, it is all yours.
Sure, and thanks, Rennie, and thanks, Steve.
Excellent.
Okay, so I'm just going to take a few minutes, and as Rennie said, I've been around the weather industry for a while. I was thinking the other day, I probably spent close to 20 years of my life combined in environmental services and selling weather information. Years ago, the hot product was a daily fax forecast. Now we've got technology in our smartphones that is absolutely mind blowing. So, what I'm going to do today is talk about proactive weather monitoring for risk mitigation. And I'm just going to jump into it here. And just keep in mind, if you have questions that we're going through this, write to the moderators, or you can write to him and he can interrupt me in the middle of it. We want to go through it. So WDT is a global aggregator of meteorological content, and we curate information from all over the world and provide that information, you can see from this graphic, through a big data engine into multiple market verticals. What's unique about this is we position subject matter experts between that data and those market verticals, whether it's entertainment, digital media, insurance, energy, offshore and onshore, cruise ships, agricultural, aviation, and helps us build a single window common operating picture across the realm here. So going forward, I'm just going to give a few definitions you hear me using here so people will have a better understanding. So when we talk about a forecast funnel, it's really a look at a single asset or a region as a weather event is approaching. And as that time and space get diminished, we narrow down the focus to let people have a real great sight window into what's happening with their local asset. you'll hear the word nowcast. That's for meteorologists, what's happening on the ground till about 6 hours in the future. You hear me mention situational awareness. I'm not going to read that definition to you, but it's just one of the most important things that you'll hear going forward is, are you aware of what's happening with the environment around an asset of your concern? I mentioned single window or common operating picture. Our reach and ability has the capabilities of providing you with the same look, feel, and style across all regions of the globe, so everybody is seeing the same information to make mission critical decisions. And daily planners and forecast tools, that's all part of what we provide to help you have situational awareness at a particular location. And we invite everybody at the end of this to get a free demo of how that all works for any assets you would like. Some of the questions: how do we as a weather company in Norman, Oklahoma serve clients with global operations? And the answer is we provide great meteorological expertise with running our own atmospheric models, global observation data, all the latest in science and tools, and then we bring that together, allowing us to have our own common operating picture view of the weather around the world. And what that allows is continuity and superior forecast, great ability to communicate to you, and then make individual high-impact decisions to mitigate weather. So what we do is, as I mentioned, we provide subject matter experts based on the market and on our meteorological staff. We also provide run our own atmospheric models and global forecasts. And then we have in-house, we run the same advanced tools that the National Weather Service uses under the AWIPS 2, which was a $500 million program that U.S. taxpayers paid for by Raytheon to build a proprietary modeling tool for the National Weather Service. We run that in-house. We have subject matter forecast experts. We run our own alerting engines outside of the U.S. I'll show you an example of that coming up. And then we can bring all that information across multi-modality platforms, whether it's mobile, whether it's desktop, across the board. Just a couple of little infographics here. Weather has dramatically increased in dollar value and damage over the last few years. You can see from this graph the event frequency and the billion-dollar disasters, and we don't see that slowing down anytime soon, with the populations moving closer to coasts and in more severe weather areas. It's an interesting one. We ran our own analysis of accuracy on tropical information last year, and we found that we were initializing tropical storm updates about on average 50 hours earlier than the National Hurricane Center. What that means in terms of mission critical operations for some of our clients is invaluable. The goal here is to be the last to close and the first to open. And I've got some samples of that coming up. I'll show you what we've done. We just launched, as part of that whole situational awareness forecast funnel, a new series of tools over both the United States, Southern Canada, and Europe. One is predicated on winter storms, and this one is a thunderstorm and rainfall planner. This is a 1 to 3 day outlook of what to expect, with a rich graphics and then a text by our meteorologist going forward. This is all part of our program. We also have the ability, if some of our clients out there, and we have clients that use this, have their own internal common operating picture software that they run their organization on, we could take all this same meteorological data and provide it to you in a series of APIs, or if you're an ESRI customer using GIS, we can provide it in GIS. And so we welcome anybody who'd like to talk to us about how to do that and incorporate high quality, high science meteorological data into your operating platform. The creme on top of all this is we have meteorologists on staff 24/7, 365, and they are accessible to our clients to talk for consultation, to talk about impacts, thresholds, those type of things. How's the weather going to affect their particular event? During last year, in a very active hurricane season, our guys were on the phone with many Fortune class companies discussing with board of directors the onset and time of departure for many of those big tropical storms. This is a really great service if you want to get a meteorological expert on the phone and chat with your group. Like I mentioned before, we provide, outside of the United States and the National Weather Service, weather warnings and that type stuff are pretty sparse to get a hold of. So we run our own global suite of, we call them halo alerts, of atmospheric warnings predicated on our clients' assets. Here's an example of a WDT high wind warning over, I think that's right in the by Greece. And these are done everywhere. So those can also be fed to you as a data feed into your platform as well, or run through our own Commander platform. Couple of examples here before I wrap up. I'm just going to show you some case studies. One of our co-op energy clients uses our dynamic planners and daily threat prediction to position crews, start and stop of repairs. This will be available afterwards. I won't read you the quote, but really great results with this, especially pre-position of crews or sending crews to get things back on top. Murphy USA, the 50-hour advance warning of tropical storms allowed these guys to modify their pricing. They made about $3.2 million off of Hurricane Harvey just by fuel prices and knowing in advance where to ship and supply and demand. Multi-asset customers such as Whataburgers use our platform for all kinds of mission-critical decision guidance for both safety of their customers, safety of their crews, and supply chain management going forward. We have a very large partner with a mass notification company called Everbridge, who is integrating our WeatherOps APIs into their Everbridge suite, which provides National Weather Service warnings, the global halo alerts, access to meteorologists, and all those daily planners on a global basis for any customer with one asset to thousands. So the three big takeaways I've got here are: weather happens. It's going to happen. We can't prevent it, but if you're proactive, you work with a consultant group like WDT and our solution experts, we're going to help you set up that location and help watch that weather for you. So if thresholds are exceeded, we're going to tap you on the shoulder and say, pay attention, something's coming. This is a key thing. You'll talk to any planners. The time to plan is not when it's happening. The time to plan is right now. And we can work with you and help you do that. Multimodality, online alerting, weather data analytics, consultation with meteorologists. We've got all the experts, everything in place. So we're going to help you avoid unintentional exposure, personnel and assets, increase your costs. Bottom line, like I mentioned before, you're going to be the last to close and the first to open. We're going to help you with all the supply chain management stuff as weather can impact that. And we even have forensic meteorologists on staff if you need professional litigation and hindcasting. We call that forensics meteorology. And it's all right at your fingertips, whether we provide you the data for your operation platform or you use our information. The weather risk information is wherever you are. And we have opened it up. If you go to weatherops.com, you can sign up for a free demo for this. No obligation. If you'd like to talk to a meteorological solution expert, we can certainly get one on the phone with you and help you talk about those type of aspects. So with that, Rennie, I'll turn it back over to you. And if you want to ask any questions or we can answer questions for folks, be glad to do so.
Sure. Thank you very much, Mike. And we did receive some questions. We have one here for Steve Strum. Steve mentioned that in April and May of La Niña years, that they could be active severe weather-wise. We were curious where you might be thinking this would be the case. What regions of the country might see severe weather in April and May?
Well, most likely we'll see, the majority of the country east of the Rockies see at least some severe weather during those months. We'll probably actually see more severe weather events happen kind of from the central areas of the Southeast, kind of Mississippi, Alabama areas up into the Midwest. We'll probably likely see more severe or more intense severe weather events happen across the plains this spring. A lot of times in these kind of setups in April and May, you may not see a large number of, say, tornado outbreaks across Kansas and Oklahoma, but when we do see them, we tend to see events that produce a large number of tornadoes and a large number of hail events, in those areas. You may not see quite as many actual days with severe weather as we will farther east. But when we do see those days happen, they likely will be sort of more intense than you would see in sort of other years. So again, that kind of the eastern plains into the Ohio Valley and down to the western southeast will likely be the focus for the most number of severe weather events. But again, probably all areas east of the Rockies will at least see sort of an above average number of severe weather occurrences during this upcoming spring season.
Sure. And another question here is regarding the drought that has kind of been ongoing in western Oklahoma, West Texas, and so forth. How can drought tend to impact severe weather season and where severe weather may occur?
Well, so one factor that we have across the plains is the location of something called the dry line, which is sort of the boundary between the very dry air that's typically in place across the Southwest and the more moist air that comes up from the Gulf. And if we do see a lot of intense drought across areas of the southern plains and that western part of Oklahoma, western Texas, that can tend to result in sort of the mean position of the dry line being a little bit farther east. And so sometimes you can tend to, shift the sort of the average area of severe weather a little bit farther east from normal. And so it can kind of sort of be a self-fulfilling type of thing where the areas that are very dry heading into spring across, the plains can just stay dry as we head through the spring season. And that can tend to, kind of cascade and kind of make the drought worse in those areas. And so we'll have to watch that. Again, having the drought there now across western Oklahoma, western Texas does tend to increase the odds that we'll see severe weather located a little bit farther east of those areas as we head through the spring season.
Awesome. Thank you. A couple questions from Mike Gothier. How can WDT benefit radio media with real-time severe weather warning broadcasting?
Radio media.
Yeah.
That's interesting. Yeah. I mean, we have the capability of providing all the watches and warning feeds live, which is the actual text from the Weather Service here in the United States and or our global stuff. If somebody wanted to get hooked up with those, they could certainly come in on a live feed. And they could certainly grab them and use them.
Sure. And another thing, our WeatherOps Commander platform, we have in the last probably year to 18 months added the radar scope component to our WeatherOps Commander platform. And so you have the ability to use our interactive mapping inside of WeatherOps Commander, look at some of the radar scope layers and identify reflectivity, velocity, hail signatures, etc., which would be useful, and also show the watches and warnings on a map, which help for tracking severe weather in real time, as well as getting forecast components there as well. And we did have one question about radar scope for Windows, there's been a lot of buzz about that. We do expect to see that in the Windows Store here in the next 2 to 3 weeks or so. So we're all looking forward to the release of that as well. So I think that'll do it with questions. We thank so much everybody joining us today and spending some time with us talking about severe weather and WDT as well. We invite you to visit weatherops.com, as you can see on the screen. Weatherops.com. You can sign up for a 7-day free trial of our service, take it for a spin, and we will have a solution expert discuss your company, whether it's large or small, and how we can help protect you with providing weather services. So thanks again for joining us. Thanks again to Steve and Mike for your information, and we look forward to talking with you soon.